Ideal gas lecture 1. Let's grab this one with 3.7 moles of the propane at the top. I don't remember what the title was, I'm sorry. Hit pause and go find it. Okay, here's the, the formula for gases when they don't change, when they're in a static situation. So if it's changing, it's the other videos. It's the combined gas law. If it's just a situation with moles in it, and if they're giving you grams or moles, this is the one you're looking for. PV equals nRT. Copy that down. Now, P is pressure again. V is volume. If you think you might forget, go take a note. N is moles. T is temperature in Kelvin. By the way, use only liters and Kelvin. Volume must be in liters. Put a note. In liters only. R is sort of a fudge factor, and it's not that we're cheating, it's that it takes all these and puts them in relationship to each other in such a way that we get the right answer. It's not mathematical cheating, but it is an adjustment. It's a conversion factor. So if you're going to use atmospheres, you got to use 0.0821. Write that down. Hit pause. R is 0.0821 if you're using atmospheres. And technically all these other units are in there too. I kind of start to skip it, and I did in the samples because it's such a lot of writing. If you're using atmospheres, you got to use 0.0821. If you're using torr, you got to use 62.36. Hit pause, go write that down on your paper. So R is one of these two. Let's try number 1, and it's just plug and chug like I said last time. There's not a lot of thought process to this, honestly. If 3.7 moles, okay, that's N of propane, don't care. It doesn't matter, honestly. We can talk about that more later. Are at a temperature of 28 C. I'm going to need that in K, so I added 273. Are under a pressure of 154.2 kilopascals. Now, I'm going to need that in either torr or atmospheres. So over here, I converted it to atmospheres. How did I know that? Because on my previous video, I showed you that 1 atmosphere and 101.3 kilopascals are the same thing. So I know the relationship between these is 1 to 101.3. That's the ratio. So I'm going to put this on the bottom so this cancels out. 154.2 divided by 101.3 gives me 1.52 atmospheres. Now I got a pressure I can work with. Pressure goes here. Volume is I don't know. What volume does the sample occupy? Volume is unknown. Anything is over 1, by the way, isn't it? And that's going to come in a little important. My moles are 3.7. They flat out told me. 0.0821 I know because I'm using atmospheres. 356 Kelvin is my temperature. The only other thing is to get the atmospheres away from the volume. It goes on the bottom. If it crosses the equal sign, it must change levels. My calculator work is 3.7 times 0.0821 times 356 divided by 1.52, and you should get 71.1 liters. And you know it's in liters because buried in the R is the unit liters, and everything else would have canceled out. Hit pause, try it yourself. Number 3. At minus 45 degrees C, time out, I need that in Kelvin. Add 273 just before you even get started. 71 grams of fluorine. Well, there's no grams in this, is there? There's only moles. Okay, convert this to moles. 71 grams of fluorine. It's 38 grams per mole. Go use your periodic table, find that. Remember, it's F2, isn't it? Because, and I know some of you forgot, but fluorine is a diatomic gas, and if it's just fluorine, it would double up. It would pair up. So it's not 1 atom, it's 2. So that 19 on the periodic table for the molar mass is doubled. It's 38. Divide, this is going to cancel, isn't it? Divide 1.87 moles. That's N. Now I can put this in. My pressure, oh, what is the pressure of the gas? In kPa. Ah, darn it, I'm going to have to convert that at the end. Let's put in my pressures, I don't know. My volume in liters, oh yes, 6,843 milliliters of space. But that's not what I can use. I can use liters. And remember, there's 1,000 milliliters in a liter. So if I'm going to use a bigger box, a bigger yardstick, so to speak, I'm going to have a smaller number. 1, 2, 3 spots is going to divide that by 1,000. So that's divided by 1,000. It is now in liters. 6.843 liters is my volume. My moles I just figured out. Let's use 0.0821 because I want to use atmospheres because it makes my converting at the end easier. You could use torr, but it's just more math. And my temperature was 228 K. Get the liters away from the P by putting it across the equal sign. It goes across, it changes levels. And your calculator work is 1.87 times 0.0821 times 228 divided by 6.843 comes out at 5.12. What's the unit? Well, I was using this, which again has atmospheres in it, so